Okay, now we are really solid on how to determine the function rule or the pattern rule that relates the input to the output. And it's time to introduce this week's new concept, using a variable to describe a pattern. Now, a variable is just a letter that's a placeholder for the input. The word variable itself means changeable, and that is a great way to describe it because really the input could be any number you decide to put into the table. So the number itself changes, hence the word variable. Let's take a little detour here. Guess what language we get the word variable from? Well, it is our old friend Latin. The Latin word variare means to change. And the word vary is an English word that also means to change. So we use varieties of the word vary in various ways in English. Do you guys see what I did there? Haha. Both varieties and various come from the same Latin root word variare. So we have variable, varieties, various, vary, all coming from the same Latin word and all meaning something related to change. So keep in mind that that word variable means changeable. Okay, back to our regularly scheduled programming. So in math, we like to use letters as variables. And you can use any letter you want as a variable, but some of the most common ones are X, Y, A, B, C, and N. Now, to avoid confusion, we almost always use a lowercase letter, and we usually write it in cursive handwriting if we're doing it by hand, or if we're typing it, we put it in italics. But really, that's just a convention. That's just a rule of what we do in math. But you could technically use anything you want as a variable, as long as you understand that it just represents a number or a series of numbers. You could use an asterisk or a question mark or a shape or any kind of symbol. The point is that the variable represents a number or a set of numbers. Okay? In this case, I'm going to use the letter N as my variable, mostly because N stands for number, and that just seems to make sense to me. So I can say my function rule the long way as multiply the input by 5, then add 3. Or I can save a little bit of effort and use the times symbol and the plus symbol. And then I can replace the word input with N and write it out like this: N times 5 plus 3. That means the same as multiply the input by 5, then add 3. Now, here's where we get into some potential confusion, though, because the letter X is probably the single most commonly used variable, but it also happens to look identical to the times symbol right here. So, to avoid confusion, we simplify it even further and we just write 5n plus 3. When we say 5n, it means the same as 5 times n, but we just take out the times symbol because it can be confusing when we're using variables. It's like, is it a multiplication sign or is it a variable? I don't know. So we take it out, okay? So remember that when we use variables, we do not use the multiplication sign. We just put the number and the variable, squish them together, and we know that it means times, okay? So 5n means 5 times n. Alrighty, when we write out the pattern rule this way, 5n plus 3, we call it an expression. Now, an expression is a mathematical statement with numbers and operations. And I usually think of expressions as kind of being part of an equation, but without the equals part. So in this case, our pattern rule, multiply the input by 5, then add 3, can be written as the expression 5n plus 3. To avoid any confusion there might be between expressions and equations, let's define the word equation. At its most basic level, it's a mathematical statement that uses the equal symbol to show two things that represent the same amount. So 1 plus 1 equals 2 is an equation. But now that we're older and smarter and we know about variables, we can expand that definition. An equation is a mathematical statement that uses the equal symbol with variables, operations, and numbers to show two things that represent the same amount. So we can actually use equations to express function rules as well. And all we need to do there is to replace the word output with a variable. Okay, so we're going to have two variables now in our equation. In our expression, we only have one variable. But our input and our output are tied together, right? That function rule ties them together. Each input can only have one possible output. So if we use a variable, let's say the letter P, to just represent whatever output is connected to a specific input, we can have an equation like this: 5n plus 3 equals P. Okay, so the value of n is going to determine the value of P, but P changes as well. Our output changes along with our inputs. All right. Now we can switch sides as well. We could say P equals 5n plus 3. And if that's confusing to you, just think about that easier example: 1 plus 1 equals 2. 1 and 1 is always going to be 2. It doesn't matter whether you say 1 plus 1 equals 2 or 2 equals 1 plus 1, it means the same thing. And we're going to talk lots more about that in the coming weeks when we think about equality and balancing equations. So this is just a little hint about what is ahead in the weeks to come. All right, back to Abby's input-output machine. We figured out the function rule, or the pattern rule that relates the input to the output. And that was divide the input by 5, then add 3. Or we could simplify it a bit and say the input divided by 5 plus 3. Okay? Now, we've been asked to write an expression that relates the input to the output. And I want you to try it yourself. Use the letter T as your variable and write the expression in this question in Edpuzzle.